Hello, everybody. So I work in the recommendations teams at Netflix, and this joint work with a lot of people. For this audience, I don't think I need to say much of what Netflix does, but just in case. As a streaming service, recommendations are critical, so members basically find the content they want, they will enjoy. And it's at this point pretty much everywhere except China. And growing at 130 million, which means lots of data to to play with it and try to improve the system. And just in case it was not clear, recommendations and kind of machine learning algorithms are really critical for the service. So this is a typical UI you will see, and basically, of course, from ordering of the rows, which videos are selected, what we call the billboard, which is the main image or video on the top, the search, kind of the whole page is basically personalized for you. And so what I'm going to be talking today is our work personalization, which I think is pretty simple to describe. Is the recommender system has already selected, let's say, Stranger Things will be a good show for you. But now we have actually multiple artworks or box arts that we can choose to display. Which one actually will help basically the user make the decision, make a better decision whether they will enjoy the content or not. And so this is basically the main goal, to choose an image that will help the user make the decision for the recommendation. And so some very classical examples just to kind of frame the problem. Let's say you have this movie, which is The Quiet American, and it's kind of a war action movie, but also has a romance plot underneath. You can imagine, you could look at some users that they have watched a lot of action war movies. Probably a picture that depicts that theme is better. While if a user is more kind of into romance movies, a different picture that depicts this other theme will be better. And another classical example of this is kind of star-loaded movies, like Pulp Fiction. You probably want to emphasize the actor or the actress that the user has engaged in the past with. And it's still the same movie, but can be perceived very different through the box art. So fortunately, this problem actually fits really well into a multi-arm bandit problem. This is a diagram kind of from textbook style. And the actions are going to be is finite, the set of images that you have for that show. The reward, you can define it in many ways, but we'll keep it simple. And let's say it's the number of minutes that the user played after seeing the image. Fortunately for us, the environment is really controlled. It's basically the Netflix app or homepage, so we have everything under control. And really the goal is, to maximize that reward over a finite number of sessions. And so, this talk is not going to be kind of to explain you all the literature of multi-arm bandits or any groundbreaking thing. It's just kind of a cool application at large scale of that framework. You can read, basically for years. So there are different strategies like epsilon greedy, Thompson sampling. You can define different environments. As I said, the objective. Even you can have continuous set of actions instead of discrete. So I won't go changing number of arms, which is important for us. But so I won't go into those things. I will try just to explain some of the details or concrete things related to this application. And so the first thing will be kind of the specific challenges. And the main one is attribution. So you have to think that the image already sits on top of the recommendation system. So let's say for a movie very well known like The Godfather, the recommender system chooses it, displays it to the user, and now you have picked the algorithm has picked an image. Did the user play, because of the image? Did the image actually help in some sense? Or the user was going to play it anyways? So you will want to detangle this difference. And of course, as any other bandit problem, you only get to show one image. So you don't know what will have happened if you had shown the other image. That's the fundamental problem. And the other specific thing is what we call the change effect. So let's say the user comes for one session. You recommend, you show one image, they didn't play, they come back 2 days later, that movie is still recommended. What do? Do you show the same image, kind of double down and see if it works, or should you change to a different image? And if you talk to people or go to Reddit, there are plenty of opinions of what you should do both ways. So we would like to learn, I guess, what is, and probably it actually depends on the user, like different strategies work for different users. So I'll deep down now in the different aspects of the framework. And probably the most important one are the actions themselves for us, are the images. And one very different thing in our application is that we actually have control of those images. Right? It's kind of, we have control of the entire loop from creation until they are displayed into the product. And so you can think that now the actions are part of the optimization if you want. You can start thinking like, okay, how many images do you want to have per show? Like what kind of images you want to have? Things like this, they can become part of the problem. And as a kind of general guideline, of course, the image has to be representative. So, if you just make a racy image, users, of course, will click. They will abandon in 2 minutes, and that's a very poor user experience, so you don't want that. It has to be differential in the sense that if all the images show the same character, all of them are going to have very similar rewards, so multi-arm bandits was going to be kind of pointless. And the last one is more where context or personalization comes into play, which is, of course, the image has to be engaging and informative, and that, of course, is going to mean very different things across many different users. So as I said, there are a lot of variants that you can use. I'm just here putting one here for illustration. So you can imagine the user comes to the system for a session. You flip a bias coin, and with probability epsilon, you say, okay, this person is going to to explore. But then, of course, you don't want to show all the images, random images, to the entire page. So you'll flip again another bias coin, which we can call epsilon show, and decide, if with probability epsilon show, you'll choose one or show one image at random from these 3 that you have. And so if the user has followed that path for that, for that show, now there's kind of a mini A/B test. You have, that is basically a randomized trial of that image. If it didn't follow that path, you go to the exploit part of the system, which basically you try to serve the best image to your knowledge with the data you have collected so far. And so for this exploit part, again, plenty of things you can do. Actually, there's quite a bit of active literature. This is just one possible example. You can imagine you have all the context from the user in that session. So it could be whatever device, time of the day, of course, some history of the user, other things. And you have the features for your images. And so now, basically, you can build, if you want, independent classifiers for each of the arms. That's a classical baseline in the literature. And so basically what it's doing is kind of trying to calculate the expected reward for that context for each of the actions. And so you score all of them with those independent models, and you just take the Rmax of that. And so this could be a possible system. But of course, what you really need is some sort of metric that tells you if you are making any progress. If you add a feature or you put a new model, are you going in the right direction? And again, lots of different options. One that works pretty well, we can call it the take fraction, which is basically you consider each image. The usual thing is follows kind of a Bernoulli distribution, the reward of each image, and you want to estimate, the parameter of that Bernoulli. So you can take from the data, in this case, 3 different users were shown the same image of Luke Cage, and only one of them played. So you can say that basically your take fraction or your Bernoulli is 1/3 probability of playing. The advantage of this is that basically you can also measure it offline for faster iteration. You can find it under replay or some other names, counterfactual policy evaluation. And the idea is pretty simple. So you have, your historical data that you have logged from what I showed before with the kind of randomized trials. And let's say now you have a new model, that your latest and fanciest model with features. So you can replay, this is where it comes from, in your historical data, what that model will have done if it was in production. And then you can compare. And of course, if the model suggested a different image than the one that was actually served, you cannot say anything because you don't know what would have happened. But if it matches, actually you can use that data. And so it's the same. In this case, we have 3 matches and 2 of them played. So you will say that the take fraction of that model is 2/3. And that allows you basically for offline experimentation. And so this is basically what we did. We tried a bunch of things. And you can see a little bit the plot on your right. The green bar is kind of the absolute baseline. It's kind of the take fraction with if you serve random images. Hopefully your policy will do better than that. And you can see already the yellow line is in the middle. Is basically the non-contextual. So you just basically estimate those per nulli per image and just show the same image to everyone, the one with highest take fraction. That's already, if your set of images is good, that's already very useful. But of course, if you add context, you can go even farther. And kind of 2 of the main lessons we had is, one is diversity is critical. So as I said before, if all your images are very similar or have similar rewards, then multi-arm bandit will not be able to do much for you. And then the personalization, like in many other recommendation systems, kind of wiggles around the popular images. So a bad image will always be bad, no matter what. And all you have is whatever top performers you have, and then the personalization will just select if they are good for different contexts or users. So I can say in this case, it's been rolled out to production, so nobody has to ask that, to all the customer base. And a couple of things that, that kind of learned when it was put online is basically it's more beneficial for the lesser known titles. And this seems kind of obvious, in retrospect, but anyways, it was not so obvious at the beginning. But of course, titles with The Godfather, for example, everybody's familiar, most people know it. They don't need the extra piece of evidence to make the decision. And the other thing is the metric I presented, the take fraction, is kind of at the title level. And so now all the images are going to compete with each other in the homepage. They are going to be one next to another. So there's going to be some sort of cannibalization, and it's not being taken into account. And this actually takes me, kind of what you can do as a future directions. The first one, of course, is, have some metric that tells you or gives you a feeling of this orchestration. So how, images being put together are affecting each other. Because this will reflect much better what happens online. And so we have an example, a classical example here for stand-up comedy. The bottom row is kind of very uniform. Everybody with the microphone is very clear it's stand-up comedy. And the top row is kind of more like artsy, I would say, or like diverse. Is what is better to do, and probably again depends on the user. So you like to understand these interactions. Another future direction is basically you can imagine that the cost of producing different artwork for all the titles that come into service basically scales linearly. You need Photoshop people or designers to produce more images, and that's not really sustainable. So with all the computer vision advances, and deep learning, really we have an opportunity, to start thinking, okay, can we actually generate the images automatically via algorithms, and we really have all the information we have. We have all the images in the past, and we know how they perform in the system, so we can start thinking about these things. And of course, the Holy Grail. So multi-arm bandits is kind of immediate reward. I mean, it's nice, but what you really care is that the users really enjoy is kind of the long-term reward of the service. So this, of course, the next step is to try to put it more in the perspective of reinforcement learning for a long-term reward. And with this, I'll be happy to take questions. There's a blog post if anybody wants more details. Yep.
Thank you very much. I kind of love it. I think it's so cool. I have a question with respect to the reward function. I'm always interested about how it really works and what we can learn from it. Did you use one, I know there's a lot of learning and this kind of thing, but did you use one reward function, or did you do some analysis of the different kind of reward function that itself is personalized?
I mean, so we use multiple. We are always tweaking it. And as I said, so, for example, this minutes play might be a good surrogate, but it's definitely not what you want to optimize at the end of the day. So, I mean, is that you can start with a very simple thing of, play, not play, and then evolve from there to a much more complicated one. So I wouldn't say we are settled in a particular one. We keep trying things.
Okay, thank you.
Hi. Nice talk. I really like the way that you stated the problem in the beginning, that you want to choose images that help a user make a decision about whether they would like the show. But then that kind of put a question in my head. It seems like a really, really great thumbnail might help a user decide that they should not interact with the show at all, that it was recommended to them by the algorithm, but they realize that they don't like it. Yeah. But that's probably really hard to track. Is there anything that you can do in that area?
So I agree. I mean, we are trying, so this goes along with the reward function. You could consider kind of, putting some basically some negative reward. But as in most recommender systems, and we saw yesterday in some of the talks, the inaction of the user is very hard to measure. You show a lot of images, and most of them are not, there's no play or there's no interaction. And to decide whether it was because, I don't know, there was just something more interesting, or it's really because it was a good evidence to not see the show. I mean, we're thinking about it, but we don't have kind of a concrete solution yet.
Okay, thanks for letting me know that Netflix isn't tracking me quite that much yet.
Let's see. Doesn't matter.
Hi, Rafael Souza from Accenture. Can you go over the difficulties, challenges in deploying this in production and doing this learning online, and what you did to overcome this?
Sorry, can you repeat again?
What were the challenges in putting this in production and maybe learning online or pre-computing things to make it more efficient in the large-scale setting you're working?
Yeah. I mean, so there are quite a few challenges. I think it's in the blog post is like something, like 20 million images per second that are served at peak time in the service. But I will say, more than the real time versus the pre-compute, which we basically have a spectrum, and different images are shown in different parts of the homepage or search, so different parts of the application, and then you can decide where it's worth going real time and where it's worth, it's not worth, so you can kind of have a more stale or pre-compute model. One of the, I would say, critical things was to really make the full connection of the feedback. So in the sense, like, track that image was shown and how many minutes it was played, making sure that all that data kind of was clean, and for the volume of data also that we are acquiring. That was, I mean, one of the challenges.
Thank you.
Yes.
So when you randomly select images for users, just the fact that you show multiple images to the same person at different times may have some impact. Yeah. I'm curious, when you say random system or even in sampling, once you select an image for a user, do you fix that image or do you completely randomize it over time?
Yeah, very good question. So I will tell you, we do everything. In the sense, actually depends on where in the page or what kind of canvas it is. We have different, basically, persistence of the image. So the system is ready, basically, it's just like a property, and you can set it to stay for longer periods of time, or just per session. And it really depends. Some canvases are more sensitive than others. You have to study, basically, what is the reaction of the user if it stays with it and those things. So the system is basically prepared to handle all the ranges.
Thank you.
So maybe one more question? Toss a coin.
Kjeld from Salesforce. So when we talked about the loss function, I was just curious, the way to define negative loss, have you gone in and looked at if a person starts a video but then don't watch it to the end, then we should actually count it as a negative thing because they didn't enjoy it and they're like not watching it all the way through?
Yeah. You can join the debate, you know, like, we definitely thought about this. And yeah, we are trying basically different ways of doing that because it's true. Like, you know, it can be a sign of abandonment. Basically, we are testing all the different options. To try to understand what it means for, you know,
Okay, thanks.
Okay, let's thank our speaker.